Okay, this is sample problem 6.7. What are the possible values for the magnetic quantum number, m sub l, when the principal quantum number, n, is 3 and the angular momentum quantum number, l, is 1? Okay, so it's important to think of this as a sort of hierarchy. N is the principal quantum number. That gives you the energy of the electron. And that can take on values of 1, 2, 3, 4, 5, 6, 7, blah, 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 as far as you want to go. Okay? So that's what you do first. You figure out what n is. Second step, L, the angular momentum quantum number. This gives us, in a sense, the shape of the electron distribution. Now this one can be 0, 1, 2, 3, 4, 5, 6, but it's limited. The highest it can be is n minus 1. That doesn't mean it has to be n minus 1. So for example, if n is 5, L could be 0, 1, 2, 3, 4, right? 5 for n, L just has to be less than 5, okay? And then the third one is the magnetic quantum number, m sub l, and that one is 0, plus or minus 1, plus or minus 2. Oops, boy, I didn't write that well, did I? Turned it into a fraction. Plus or minus 2, plus or minus 3, 4, 5, 6. The highest it can be is plus or minus L. Okay? That's determined by L. The limits of m sub L are determined by L. So what you do is you look at n, then L, then m sub L. So let's take a look at this example. N equals 3. If n is equal to 3, L can be 0, 1, or 2, right? Because all of those values are less than 3. It can't be equal to n, but it can be less than n. So for n equals 3, there's 3 possibilities for L. L could equal 0, L could equal 1, and L could equal 2. By the way, for n and L, we generally don't put a plus sign. We can put a plus sign for the m sub L values, though. So now here's what happens. Suppose L equals 0. M sub L, the highest it can be is plus L. But the L is 0, that means that m sub L, the highest it can be is plus 0, which is just 0. The most negative it can be is minus L. Well, minus 0 is still 0. So if L equals 0, m sub L has to equal 0. Okay? Now this is shown in table 6.2, but it would be great if you could figure this out on your own without that table, just using these 3 relationships here. Now, what if L is equal to 1? So again, this is still under n equals 3. If L is equal to 1, then m sub L can be 0 plus or minus 1, but L is 1, so we would stop right there. If L is 1, we don't go any further with the m sub L. So it could be 0, it could be plus 1, or it could be minus 1. All 3 of those possible values, okay? So that means, we'll see later on that has ramifications for where we put electrons, but what that means is there's 3 possible values. It could be 0 or plus 1 or minus 1. Now, in this particular problem, they say L equals 1, so there's your answer. M sub L could be 0, plus 1, or minus 1. But suppose that L is 2. That means m sub L could be 0, plus 1, minus 1, plus 2, minus 2, right? Because you're going to go all the way up to plus L and all the way down to minus L. So if L is 2, you go from minus 2 to plus 2. So generally this is written in increasing, it's a series. So you generally write it as an increasing series. Minus 2 up to plus 2. So those are all possible values. Okay.